So here we're supposed to graph the exponential function, and it's in the form of f of x equals a times b to the power of x. So a in this case is 3 halves. Our b value is 3, and then our x is just x. And here we're looking at the function g of x, right? So we're going to plot 5 points on the graph of the function, and then click the graph of function button. Now, in order to do this, you have to make a table. I'm going to plug in 3 values for x, and some values for x that I want to go over are what happens when the exponent is 0, and when it's 1, and then when it's just any other positive number, okay? So I'm going to graph these 3, and then you can go from there, okay? And here we have g of x, right? So wherever you see an x, you're going to replace it with this value. So here I'm going to show you what it would look like, all right? So here we would have g of x, excuse me. So this would be g of 0, right? We would have 3 halves times 3 to the power of 0. Now, whenever you have something to a 0 power, that is just 1. It doesn't matter what you're putting to the 0 power, the answer is always equal to 1. So this is going to be equal to 3 halves times 1. And anything times 1 is itself, so the g of x is 3 halves. So if we are putting in our ordered pair, we're going to plot the point at 0, 3 halves. And think about where 3 halves is. So 0 is here. 3 halves would be just a little bit above 1. It's 1.5, right? So we would have a point right there if that's 2. All right, now we're going to go ahead and do the same thing for 1, right? Whenever you put something to the first power, think about how that affects it. Well, when you're putting it to the first power, you're saying it's not even times itself, it's just itself. So this is going to be whatever the base of the exponent is, in this case 3. So here you have 3 halves times 3, which if you multiply 3 times 3 is 9, so that's the same thing as 9 over 2. All right, so you could write this as 9 over 2, or you could also write it as, what is 9 divided by 2? It's 4.5, right? So you could write it as 4.5. So when you're at 1 on the x, you're already up to 4.5 over here, right? 3, 4, 4.5. That's your 1. Then you're going to plug in a 2. So let's substitute 2 for our x value. Oops, forgot the 3. So 3 squared is equal to 9, right? So 3 halves would be multiplied by 9. So this is going to be equal to 27 over 2 now. You see how it's growing exponentially, how it grows much quicker than a linear function? So 27 divided by 2, well, 26 divided by 2 would be 13. So this must be 13.5 or 13.5. So as you'll see, we're already double. We're like off of the grid already. What ends up happening is you have a line that kind of, a function that kind of curves up like this. So whenever you graph an exponential function, you'll see that it takes one of several forms, right? It'll either be curving up, depending on if these numbers are positive. It will be curving down if the a value is negative. It could be going down or curving up if you have a fractional b value, or depending on the orientation of the a value. Okay, so you don't really need to know these things, but this is a general behavior of the exponential functions. In this case, you're just plugging in and creating a table.